I think most of you have heard of the Internet of Things. Unsurprisingly, it's made of things which connect to the Internet. But how do you get the Internet to your thing kilometers away from Wi-Fi? Let's give a warm welcome to Tobias and Per, who are going to connect the dots for us.
Yeah, welcome and thanks for coming, all of you. It's still the first day, so I feel I just arrived, so welcome to the 35 Chaos Communication Congress. We want to show you today how you can build your own devices, like you said, using Arduino or some other cheap building blocks to build your own sensor and connect it to the internet. We have one example, which when I start, like, whoa, that's right. Let's assume you have a fine dust sensor and you want to measure the fine dust level in Leipzig. You can deploy them at all the points where you want to measure it, like near the highway or in some living area. What we need next is some internet. Best internet at the moment is probably here at the Chaos Communication Congress, thanks to the NOC. And well, the question is, how do you connect your sensors with the internet? Since we don't want to dig holes and draw wires, we do it wireless. And that's where we use LoRa. And LoRa is a wireless radio technology that's designed for low power usage. It has great coverage at range over several kilometers. Even with this low power usage, it is cost efficient. So you basically buy the chip and then you're good. You don't have any additional cost as with GSM. And the data rate is pretty low, but well, we only need a few bytes every few minutes, so that's totally fine. What we actually did was a project with a student from Hamburg. He had his master's thesis and he wanted to collect these fine dust data. And we created a sensor, or built a sensor for him, where we connected his low-cost Nova Fitness fine dust sensor with some other sensors with a radio module. This one was actually from IMST. There are several on the market that you can use. It's a module where you have the radio transceiver and a microcontroller on it. We connected this with a battery supply and gave it to him so he can collect his data. And there's actually another project that I want to advertise a little bit. It's the Luftdaten.info project, where they also collect Luftdaten or fine dust data all over Germany, all over the world, but mainly with Wi-Fi based boxes. And we want to push the idea a little bit to do this with LoRa in future, maybe. Because then you don't need your local Wi-Fi and everything. So, yeah. After, I want to start with basically you need two things to connect your device. You first need the LoRa communication, which is a pure radio transmission, which is when you know the OSI layer model on the physical layer. And then you need some kind of wide area network infrastructure, which will be explained by Per later. That covers mostly all of the other layers, from data link to session layer, maybe a little bit of the presentation layer as well. So let's start with the LoRa transmission. It's it's a little bit it has some parameters. So you can use the frequencies, at least in Europe. It's a 685 kilohertz to 1 gigahertz band. So we cover the free 868 megahertz band, where you can deploy your own devices when you keep with the regulations of the EU. You're also limited by the EU to like 40 dBm for transmission power. And the bandwidth can vary between 125 kilohertz at LoRaWAN to 500 kilohertz. And then you have a special factor that's kind of special for LoRa that you don't find in any other technology. That's a spreading factor. And when you see at the, I don't have a laser pointer, but if you see at the graph where you have the time from the bottom to top and the frequency from left to right, then you can see that LoRaWAN or LoRa is working with chirps. So it modulates the frequency over time, and that it's how it somehow encodes ones and zeros over the air. For the exact details, you can see the talk from 2 years ago, yes, from Matt Knight. He digged into this because the technology is proprietary by Semtech, so you can't find any open documentations, but this talk is kind of like a documentation about it. So with the bandwidth and with the spreading factor, you can have pretty much influence on the link budget. So the link budget can go up to 151 dBm, which means that you can, in the free field, or how it's advertised, you can get up to 15 kilometers. In praxis, when you're in the city, or normal environments like here from hall to hall, you can get like 3 to 5 kilometers, or indoor maybe 1 kilometer. So it's highly depending on where you are. Data rates are from very low, like 32 bytes per second, but up to over 1 kilobyte per second. And maybe one thing to the spreading factor. So spreading factor 7 is where you have the highest data rates. So when a signal takes, let's say, 20 seconds on spreading factor 7, it will 20 milliseconds on spreading factor 7. It will take twice as much on spreading factor 8, and then it doubles to spreading factor 12. So that's basically the parameters you have, and how to use those parameters, and how to set up your radio, and how to set up the gateway that receives all your messages. There's a wide variation of parameters. This is all defined in LoRaWAN later. And when you build a LoRaWAN compatible device, it will just talk with the network that Per will explain soon. So, does it actually work? Yeah. We are building sensors since over 2 years. We also built our own LoRaWAN stack on hardware using the IMST module. If you have any questions also about the LoRa details, since we don't have a Q&A after this talk, you can also come to our assembly. And now I will hand over to Per, who can explain how the wide area network works.
Thanks. So now you know about LoRa and how it works and why it's pretty useful. But LoRa is only just, you have a few bytes which are thrown into the air, and the rest is up to you. Granted, it throws them pretty far and with only very few energy used, so it's good for IoT devices. But you have to do everything else yourself, like where does the data get, how do I know it's from my device. Luckily, there is something called LoRaWAN, which does all these things for you already. You have your devices. They look a bit like razor blades in this graphic, I think. Those are your devices in the field. You have data there you want to have somewhere else, and that somewhere else is over there on the right, the application server. That's where you want your data. And how do you get it over there? Well, LoRaWAN adds 2 more parts to the network. You can see these rectangle parts. They are the gateways, which are the pieces of hardware which do the wireless communication with your device. And they are controlled by something called a network server, which is the most intelligent part of the whole system. And they get the data to your application server. This graphic I used from the Things network. It's so handy for explaining that we'll take it along with us to the talk. So to get an idea, we'll just build a small device just now because that's easier than explaining it like just from far away. So what do we need? 4 parts: a device, a gateway, a network server, and an application server. We started with that. That's the fun part because that's what you want to do. That's your idea. Put it out there, and now we have to connect it. You can get one device for pretty cheap actually. You can use an Arduino, which you can pretty cheap. You have seen the modules for LoRaWAN, which Toby showed, and some power connection, and that altogether is about 10 to 20 euros if you know where to look. The next part are the gateways. Those are a bit more complicated because they are a bit expensive. There are many different varieties, but if you're lucky, there's already one around. Like at the Congress, there are some I've checked. So, and the network server, well, that's pretty much done already. There's something called the Things network, which is free and open and with a sharing community. And the last thing is, well, your application, whatever you want to do. We'll look into the 4 parts in a little more detail now. Oops, sorry. So what do we build as a device? We could use the finder sensor, or we could something really useful for something like this Congress, which is, well, an alarm button you press when you see some cyber at the Congress. So what's in there? Actually, not much. There's an Arduino, there's a module, and some power supply. Well, and you need, of course, a button to trigger the button. With this project, the button costs about twice as much as everything I put inside, but that's okay because the button is also the case I used for this. So you can see my lovely soldering skills there. If you looked at the parts earlier, you probably thought, well, there's something missing in there. Don't we need an antenna? Yeah, right. But I skipped over all the cables I used, and if you see that tiny yellow wire on the left, that's actually the antenna I use to communicate over radio. Of course, there's much room for improvement. You could get a better antenna and get more range, but this actually works quite well. I've tried it. So what do we have? We have this thing I call the cyber alarm. I built this. This is complete and no wires, as you can see. It's, of course, programmed. Well, it's Arduino, so how does it work? You get the Arduino library, you start from the example and add the parts you need, and then you're done again. I've walked along about this project. I've linked here. It was the GPS tracker. So GPS tracker is much more complicated than just having a button. But if you go there, you have a good manual how to do all the thing. So the gateways, the magic parts. They are actually pretty dumb devices. They just packet forwarders. They just collect every LoRaWAN packet that is out there in the air, and they pass it on to the network server. And when the network server tells them to send something out, they do that. There's a great variety of what kind of gateways exist. I put, well, the upper end and the lower end, I would guess. This is an industrial standard called curling, costs about 1,000 euros if you put it all together, but has intrusion detection, GPS, has this mobile internet, and everything you would want to just put up your gateway. If you're a little short on the money, well, you can use a Raspberry Pi and this module. This altogether is for about 150 euros. You could get that. We actually have one of those in our office for our development process, and it works quite well. So if you put it up on your local hackerspace, you have coverage for quite a few kilometers if you have a good antenna. So the next thing is the network server. As I told you, that one is done, but that is the most complex part, and it does everything for you actually. There's this free network server. You can just go there and register your device. It's a bit like Freifunk, but for IoT and not for Wi-Fi. You just go there, you say, get your account, you say, well, this is my application, in my case, cyber alarm, and this is my device, I want to register it. And it handles the session when you log on, it handles the encryption, it even handles the decoding of the data, because you get just a few bytes up there, but you can insert piece of JavaScript which will decode them and send you a JSON to wherever. Let's just take a quick look. Well, this is device registration. The most important part is there's these 3 columns of numbers. The first one is the device EOE, which is just the address of this thing. It's like a MAC address for Wi-Fi. The second reference is which application I use, and the third one you probably don't want to show because that is the secret you use for putting up the session and doing the encryption. But this is no real data. You cannot use that for anything. That device doesn't really exist. So you still need to reach your application server. That is quite easy because the Things network does everything for you anyway. There is a protocol which is the easiest to use. It's called MQTT, which is a lightweight message protocol for IoT actually. And if you use Python, you're of course done because it's Python. There are other ways to connect your thing. You can put up a hard HTTPS requests, or you can have something like if this then that network. But we just did this, and it's actually that short that I will show you the whole script. This would work. It's just import TTN, put up your handler. Well, I didn't put my key there, but you probably would. And this would actually work. My script, which I'm running, is a bit longer, but we'll try if it works. Yes, it did work. So, what happened? Thanks. So what happened there? There's this chip, you've seen it. It just sends out the message. There are gateways for the Things network at the Congress. As I told you, this is some kind of open network, a community. If you put out more TTN gateways, anyone can use them, and you can use their networks, their gateways. So normally, well, they're not that far spread yet. In Hamburg, we have about 7 or 8, I guess. Some of us are VIRs, but we have a basic coverage if you want to do that. I have one like a kilometer away from where I live, and it works. Leipzig now only has 0. I checked, Toby checked 2 hours ago. There are about 4 now, but they are for some reason all at the mess. I don't know why. Yeah. It didn't fail, so that's good. You can also see all the alarms triggered on that URL. And if you want, you can build your own button. The code is on GitHub. You will need access via us, so you have to contact us. Then I can register your thing, and then you can also trigger the same cyber alarm I have, and we can hook it up to do whatever. If you want to reach us, that's pretty easy. We are over there, the hall. It's a deep cyber assembly. Just come over, talk to us. We are happy to talk to you longer about LoRaWAN. You can fetch us around here after the talk if you want. Also, well, there are some URLs where you can reach us. You can see us on Twitter. My deck doesn't work yet, but it's the first day I'm starting to do that.
But yeah, so we have 2 minutes left, so maybe we can have 1 or 2 questions. I don't know how the timing is.
So we were faster than we actually thought, but I don't know if the microphone's are ready.
Yeah, maybe one thing to the last link. So that's some manual how you can set up your own private LoRaWAN network. But if you connect your gateway to your local network, then of course it's not connected with a public network. And yeah, they are working on this as well. Well, yeah, feel free to ask us anything.
So thanks so much. Let's have a big round of applause for our speakers. So we have time for 1 question. And first, I'm going to go to our signal angel to see if the internet has any questions. It looks like the internet does have a question.
Oh.
No, the internet does not have a question. That's very strange. So if anyone in the audience has a question, we have a microphone over there, and we have a microphone over there, and whoever gets there first gets to ask their question. 5, 4, 3...
I was running up.
Someone is running to the microphone. Great. Good. Microphone to my left.
Is it bidirectional? So can you send messages back to your button if you programmed it?
Is it bidirectional? Yes, it is bidirectional. I skipped that part. You can have messages sent from your server to the device, but it's of course limited. Your device needs to listen. And the only way I ever used it is when your device uploads a message, then the network has a chance to send a downlink. And well, there are other methods, like you can have a permanently listening device, but I've never seen it in the open.
Yeah, there are three modes. It's called A mode, A, B, C mode, and they are a little bit different. So on C mode, the device listens all the time, and B mode, the device talks to the network server to tell the network server when it's alive.
Okay,
Yeah.
10 seconds. One thing I forgot. LoRa is not open. It's proprietary, but the LoRaWAN is pretty open. It's a spec. You can read it and build it yourself if you want and use it, whatever way you like.
Tobias, Per, thank you so much. Let's have a final round of applause.
Thanks for having us here.